All right, in this video, we are going to go through the Unit 8 review, starting with the area and volume multiple choice. For number 1, we are looking for the region enclosed by the x-axis, the line x equals 3, and the curve square root of x. And we're going to take this region that is bounded by those 3 pieces, and we are going to rotate it around the x-axis. So we always start off if it's disc or washer and it's touching that axis we're rotating around the entire time that it's touching the shaded region. So this is going to be a disc problem. And we know it's rotating around the x-axis horizontal line, so everything is going to be in terms of x's. So it goes from 0 to 3 of my radius length, and the radius here is going to go from the curve to the red line. So the curve is the square root of x minus 0, which we don't need this minus 0, but it's going to be the square root of x, radius squared, dx. Now this one's no calculator, so let's simplify. So I'm going to simplify it to integral from 0 to 3 of x dx. My antiderivative is going to be 1/2 x squared, evaluated from 0 to 3. And then I'm going to plug in f of b minus f of a. So the pi stays out in front. F of b is going to be 3 squared, which is 9, divided by 2, minus plugging in 0, which is going to be 0. So my answer for this one is going to be 9 pi over 2. All right, then for number 2, we're looking for the area, all right, area, not a revolution, of the region bounded by x equals 0, x equals 2, y equals 0, which is going to be the x-axis, and e to the x over 2. Now, e to the x and e to the x over 2 is going to be an exponential graph here. So it's going to look like this. And this is the area that we are trying to find, the area of this region. Now, when it's area, not a revolution, it's just big curve minus small curve. So the big curve, the upper curve, minus the lower curve over that piece that we're looking for. Nothing's squared, no pi in front. So this is going to be the integral from 0 to 2 of the big curve, which was green, minus the lower curve, which is just going to be 0, dx. So with the minus 0, this is going to be just looking at a u sub problem. So we're going to make the u for my integration x over 2. So du is going to be 1/2 dx. So that my integral then becomes 2 integral from 0 to 2. Oh, not 0 to 2 anymore. We're going to change our bounds. We're doing u substitution. Of e to the u du. But then it's not going to go from 0 to 2 anymore because we're going to change it in terms of u. So here's my u right here. So we're going to take 2 and we're going to plug it into u. 2 divided by 2 is 1. We're going to take 0 and plug it into the u. 0 divided by 2 is 0. Integral of e to the u is e to the u, evaluated from 0 to 1. So plugging in 1 is going to be e, plugging in 0. Anything to the 0 power is always 1. So my final answer here will be 2 times e minus 1, which is right here for as C. All right, number 4, or number 3. Okay. All right, the region in this one is bounded by the x-axis and part of the graph of cosine x between negative pi over 2 and pi over 2. So we know it's going to go with the x-axis, and we know we're going to go from negative pi over 2 to pi over 2. And for cosine graph goes through 1 at 0. So it's going to look like this. All right, and the region is separated into 2 regions by the line K. All right, and then as it's separated by the line K, we know that this region is 3 times this region over here. And we are trying to find the value of K. All right, so the first thing that I would do is let's find that area of the region. So we know the area of the region is going to end up being from negative pi over 2 to pi over 2 of cosine x minus 0 dx. So the antiderivative of cosine is going to be sine of x evaluated from pi over 2, or from negative pi over 2 to pi over 2. So plugging in f of b is sine of pi over 2 minus plugging in the sine of negative pi over 2. Now my sine at pi over 2 is 1, and my sine at negative pi over 2 is negative 1. So the area of this whole graph right here is going to end up being 2. Now really this is 3 parts to 1 part. So if we break this up, this 2, and we break it up into 4 parts, all right, 4 equal parts, each one ends up being a half of the value. Because there's 3 parts on that side to the left of K and 1 part on the right of K. So let's actually solve for K. Now that we know the area here, all right here is 1/2. I'm going to go the integral from K to pi over 2 of cosine x dx is equal to 1/2. So the antiderivative, just like we did over here in the green, is going to be sine of x evaluated from K to pi over 2. And I know that answer should be equal to 1/2. So plugging in pi over 2, sine of pi over 2 is 1 minus my sine of K equals 1/2. So that I have negative sine of K equals, subtract the 1, I'm going to start solving for K. So 1/2 minus 1 is negative 1/2. Divide by the negative 1. So sine of K equals 1/2. And where does my sine equal 1/2 on my unit circle? Sine equals 1/2 at pi over 6.